Imagine a man naked running through the streets shouting, "Eureka, Eureka!" This is not a scene from a comedy skit, but the story of the Greek mathematician Archimedes. He was faced with a perplexing problem, a royal dilemma, to verify if a crown made for King Hieron was indeed pure gold. Despite his genius, Archimedes found himself stumped. However, inspiration struck in the most mundane of places, a bathtub. As he stepped into his bath, he noticed the water spilling over. He realized that the displaced water was equal to his own weight. An idea sparked. Gold, being denser than other metals, would displace less water. By comparing the amount of water displaced by the crown and that of an equal weight of gold, he could determine the crown's purity. And thus, in his birthday suit, he sprinted through the streets of Syracuse proclaiming his discovery. It was this moment of realization that gave us the Archimedes Principle. Now, you might be wondering, what exactly is this Archimedes Principle? Well, let's delve into this remarkable concept. The Archimedes Principle is a fundamental truth in physics that explains why things float or sink. It states that the buoyant or upward force acting on an object submerged in a fluid is equal to the weight of the fluid that the object displaces. In simpler terms, if you drop an object into a liquid, it will push some of that liquid out of the way. The weight of the liquid that gets pushed aside is exactly equal to the upward force that the liquid exerts on the object. Now let's tie this principle back to our friend Archimedes and his Eureka moment. Archimedes, tasked with the mission of determining if a crown was made of pure gold, used this principle ingeniously. He knew that gold was heavier than other metals. So if the crown were pure gold, it would displace less water than a crown made of a less dense metal. So imagine Archimedes with his bathtub. He noted how much water his body displaced when he got in. If he were to place a pure gold crown in the tub, it would displace an amount of water that's equal to its volume. Now, if a less dense metal was used in the crown, even in a small amount, the crown would have to be bigger to have the same weight as a pure gold one. A bigger crown means more displacement of water. By observing the amount of water displaced by the crown, Archimedes could deduce whether the crown was pure gold or not. If more water was displaced than what pure gold would cause, he could confidently say that the crown was not pure gold. Thus, he used the principle of buoyancy to solve a problem that seemed impossible at first. And that, dear viewers, is the ingenious principle that Archimedes discovered. So let's take a moment to recap what we've learned today. We dove into the story of Archimedes, a man so dedicated to his craft that he ran through the streets without a stitch on, all in the name of discovery. This legendary Eureka moment led to the formulation of what we now know as the Archimedes Principle. It's a simple yet profound concept. The buoyant force on an object is equal to the weight of the fluid displaced by it. This principle doesn't just belong in a dusty old physics textbook. It's alive and well in our everyday lives, playing a key role in determining the density and purity of objects, just like the crown of Hieron. So, whether you're a scholar, a goldsmith, or a bath enthusiast, there's a bit of Archimedes in all of us. From a bath to a crown, that's the journey of the Archimedes Principle. Remember, the next time you take a bath, you might just have your own Eureka moment. Stay curious, folks.